guys, it's Mrs. Metter again. We're going to begin Unit 2. And Unit 2 is all about populations and lastly, human populations. So before we get to the human population part, we're going to look at a lot of aspects of population ecology when it comes to the environment and how animals and plants tend to structure themselves within environments. So let's go back to the very basic level of structure. When we look at population dynamics, we can see different levels of complexity within the environment. Okay, so we're going to start off from smallest to largest. So we're going to start off with the individual. Okay, when you have more than one individual, you are then going to have a population. Okay, a population, when you have multiple populations living together, that's called a community. Now, I want to focus on these two words for a second because population refers to the same species. So we talk about a population of people or a population of giraffes, a population of fire ants, whatever it is the same type of organism that can interbreed. Okay? Now, a community, there's going to be different populations. So different pops. Okay? Different populations. So this is when we see a herd of elephants living with a herd of giraffe, living with a herd of zebra, living with lions. Okay, so I've just described the savanna. That is a community. All right, now, when you take the community and you add in the abiotic components, that creates what we call an ecosystem. Okay, so right here, we're throwing in abiotic components. Hopefully you remember from freshman biology that abiotic means non-living. It does not mean dead. It means non-living. So abiotic components are going to be things like air, water, soil, etc. Okay? Now, when we take all of the ecosystems on the planet and put them together, we create the biosphere, which is the planet Earth. Okay? So in this class, we're actually going to be going through each one of these levels, not so much the individual because that's more biology. We'll be going through each one of these individuals throughout this course. So right now, we're going to be starting off with populations. Okay? Now, when we look at how to measure a population, there's two specific factors that we look at. Okay? We look at births and we look at deaths. Okay? Let me scoot this down a little bit. Births and deaths. Now, if I were to ask you, what is the population of the United States? Well, the population of the United States is roughly 360 million, give or take a few 100,000. Okay? So, births and deaths factor into determining population sizes. Okay? Now, these are not the only two ways that populations change. Okay? There's two more factors that cause populations to change. So we look at immigration and emigration. And a lot of people get these two words confused. So birth is obviously going to be an addition to the population. Immigration is also an addition to the population. And the way that I remembered the difference between immigration with an I and immigration with an E. Immigration with an I means to come into a location or a country. See, they both start with I. Okay, so both of these are going to add to our population. Now, what's going to decrease the size of our population? Deaths, obviously, because that person is no longer a part of the population. And then when people leave the country. So immigration with an E means to exit. Okay, see, they both have an E. So both of these are going to take away. So I told you guys this unit had some math in it. So we're going to start learning some of our equations. So the way that we calculate a population size, we talk about what goes into. So birth plus immigration with an I. Okay, we add those together. And then we subtract that from what causes a population to decrease. So that is our death minus our immigration, or sorry, plus our immigration. Okay, and that equals our population size. Now don't freak out too much about this. We're going to do lots of practice with these problems when we get to the human population portion of this unit. Okay, but this is something that you'll need to remember for the future. Okay, all right. Now, when we're looking at a population itself, there are different characteristics we look at, and we're going to look at each one of these individually. Okay, so the first thing, obviously, is the total number. Yes, we care about how many individuals there are in a population. So that's our total number. Okay. We also look at the density. The population density is the number per unit area. The number per unit area. So what this means is how many people or how many cows, for example, are located in a specific measurement of land. So in Arlington, what is the population density of Arlington? You would say it is so many people per square mile. Okay? They will always give you the area when describing density. All right? The next aspect is distribution. How are they spread out? What pattern do they have if they have one? The next is sex ratio. Okay, this is not how often organisms are having sex. The sex ratio is talking about gender, male versus female. And then lastly, the age structure. Do we have more younger people? Do we have more older people? And this is primarily going to be when we talk about human populations. So we'll get to that shortly. Okay, so the first thing we're going to look at is population distribution. So that is what these images down here are referring to. So over here on the side, I'm going to write down population distribution. There are 3 patterns that we look at. So I'm going to get my highlighter right here. So we look at what's called clumped. Okay. In clumped, you can see that they are living in groups, and this is what elephants do a really good job of. Okay. So I'm going to go back up here to my pen, if it will cooperate with me. Okay. So this is where we have groups. Okay. Then we have uniform. So in uniform, you can see that there is a set pattern. They are evenly spread out. Okay, so we can say this is pretty much even. Okay, even space. They're spread out uniformly. our last one is random. So when we talk about things being random, there's really no set pattern to them. So with random, we say there is no pattern. And so dandelions are a really good example of that. And, you know, when you guys pick up the little dandelion and you blow on it and make a wish like you did when you were a kid, that's what creates that pattern, because the wind is carrying those seeds to where they are eventually going to end up. Okay. Now, we have what are also called density dependent and density independent factors. So these are aspects that can also impact the population size. Okay? So both of these influence population size. Both influence population size. Okay? All right. Now, here's what is the difference. What exactly is happening within the environment that is going to cause essentially the population to change? Okay? So, in our density-dependent factors, this one basically means that the more organisms, the more animals, the more people there are in a location, the higher chance you have of dying. Okay? So, for this one we say the size impacts the survival rate. Okay? So if you have a larger population, you have an increased chance of scarcity in food, water, and you have an increased chance in disease. Okay? So these are things that can impact your survival rate. If you don't have food, if you don't have water, if you have disease, you have a greater chance of dying. Okay? Density independent factors mean that it is not based on the size of the population. So the size of the population really has no effect or doesn't make a difference. Okay? So we say the size of the population has no effect. Okay? So these are things that are going to be outside of the control of the individuals that are living there. So things like natural disasters, hurricanes, tornadoes, floods, we obviously can't control those. Okay? And we can also throw climate change in there as well, because climate change is causing major impacts across the globe. Okay, so this is the first page of Unit 2. I will be recording another video for our next page.